Good afternoon, class. You guys had some homework. The homework was exercise. One point three. Any issues there? Was there any problems that you guys had with 1.3? Did you guys do the work?
Yes.
So 1.3 is behind us. 1.4? What did you have to do at the 1.4? Second and third column. Any issues here? Any problems here, people? Then we did example 1 and 2 yesterday. Then I gave you exercise 1.5, the first column to do, not so? 1 to 13. Any issues there? Homework is the exercise 1.5, the even numbers. The whole column, 1.5, the even numbers. Okay? Which page is this on? Page 10. Like the sum down. So what's the difference between this equation and the equation that we dealt with yesterday? A 0. They have a 2x in the exponent. Can you see them? Okay. Okay. So there is more than one way of doing this. Okay? But the easiest way that I've found over the years is to introduce a k to the sum. Okay. So what we're going to do, if we do what we did yesterday. Yesterday we took out the common factor. Not so. If we're going to take out the common factor here, 2 to the x. Then I'm left with 2 to the x minus 3 minus 4. Then there's nothing I can do with that. Not so. So what I do is I introduce a k. Now remember, this here, 2 to the 2x, can be written as 2 to the x, 2 to the x squared. Not so. So I think to write it in terms of the middle term. Okay. So if that is the case, we're going to say net k equals, remember we're introducing a variable to the sum. So I must say what the variable represents. Whenever you introduce a variable to the sum, you have to do this. Okay. Let k equals 2 to the x. if k is equal to 2 to the x, then this here can be written as k squared minus 3k minus 4 is equal to 0. So what do we see now? Trinomial. So factorize the trinomial. Okay. So what does this factorize into? K and K. 4 and 1 minus 4 plus 1. You all agree with that? So what do I do now? Solve for K. So K minus 4 equals 0. So K is equal to 4. Or K is equal to negative 1. But what is K? What is K? 2 to the x. 2 to the x equal to 4. Or 2 to the x equal to negative 1. So let's see here. The base of the same exponents are equal. So I can write 4 as a base of 2, not so. So 2 to the x is equal to 2 squared. Therefore x is equal to. What can you say about the other side? Can negative 1 be written as a base of 2? No. So what's going to happen here? Put a line there, or you can write no solution. Either you just put a line through there, or you write no solution, one of the two. Okay. Any confusion there, people? So let's look at exercise 1.5. We're going to do number 15, 17 and 19. Exercise 1.5, 15, 17 and 19. Pause the videos now. Alright, so the first one, we say let k equals 3 to the x. So we got k squared minus 4k plus 3 equals 0. That's all. So now we trinomial. Factors is k and k, 3 and 1. What about the signs? Same sign. Not so? So what can we say now? So k minus 3 is equal to 0, so k is equal to 3, or k is equal to? What is k? 3 to the x. So 3 to the x is equal to 3. I'm getting it from here. Or 3 to the x equal to 1. So what can I say here? Therefore, x is equal to 1. Or 3 to the x is equal to 3 to the 0. Anything to the power 0 equals 1. Therefore, x is equal to. You guys get that right? Any confusion there? Let's look at the next one. So we say let k equals 2 to the x. As you can see, that can be written as 2 to the x squared. So what can we say this would be? K squared plus 7k minus 8 is equal to 0. Trinomial. As the trinomial can factorize into k and k. 8 and 1. So that is minus, so one bracket must be plus and one must be minus. The bigger product must be plus. So at this point we say k plus 8 is equal to 0, so k is equal to negative 8. Or k minus 1 is equal to 0, so k is equal to. But what is k? 2 to the x is equal to negative 2 cubed. Is the basis the same? No, so this one is not going to work. Let's say it's there. What is k? 2 to the x. So 2 to the x is equal to 2 to the 0. Therefore, x is equal to. You guys okay with that? So that's 1.5, page 11, number 19. What do we say here? Here we can go straight and say let k equals 3 to the x. So if I replace k here with 3 to the x, what would it be? K minus 6 minus 27 over k is equal to 0. So what's your LCM here? K. So I will multiply throughout by k. So that's going to give us k squared minus 6k minus 27 is equal to 0. Again a trinomial. Okay? That's going to give us k and k. 27 is going to be 9 and 3. Do we add or subtract our products? Subtract. It's minus plus. So k minus 9 is equal to 0. So k is equal to 9. Or k plus 3 is equal to 0. K is equal to negative 3. But what is k? 3 to the x. So 3 to the x is equal to 9. So 3 to the x is equal to negative 3. Okay? This one here is not going to work. Not so? There's no basis there's no way that those bases can be the same. Either this one here, 3 to the x is equal to 3 squared. Therefore, x is equal to. Okay, is there any confusion here, people? You all understand? So you should be able to do exercise 1.5, the whole second column. Okay. Solving equations with rational exponents. This is on page 11. Solving equations with rational exponents. When solving equations with rational exponents, we need to ensure that the answer is a real number. Okay. The definition, remember from last year, we said in grade 9 as well, the nth root of a to the exponent n is equal to a to the m over n. Okay, this is this part here. We will use this definition to solve equations with rational exponents. Example, the cube root of a squared can be written as a to the 2 over 3. Remember, the root will always be in the exponent's denominator. The cube root of b, remember b's exponent is 1, so that can be written as b 1 over 3. The fourth root of p cube, that's going to be 3 over 4, p 3 over 4. The square root of x is going to be x to the 1 over 2. Remember, there's no number here. There's a 2 there, and on the x is a 1. Okay. By definition, we know that the square root of 25 is 5. The square root of negative 25 is negative 5. And plus minus square root of 25 is plus minus 5. All this we knew from grade 10 syllabus anyway. Okay. Now we're looking at examples on page 12. Okay. Yeah, two sums there. So we've got the square root. X to the half equals 3. The question says solve for x. And also we got x to the half is equal to negative 3. Try and solve those two sums quickly. Now pause here. Yeah, there's more than one way of doing this. Okay. More than one way of doing this. So let's look at the first one. I can raise this exponent to its reciprocal, which is 2 over 1. Remember, the idea is to get x on its own. Okay? So that is simply going to be x is equal to 3 squared is? No, not so. Or you could have said that we have x to the half is equal to 3. This can be written as a square root of x is equal to 3. Not so. Square root of x equal to 3. How do I get rid of the square root? Square root. So what do we get? X is equal to 9. Okay. What would this one be? X to the half equals negative 3. What would this one be? I'm going to square both sides, not so. It's going to be wrong, but just check it. It's going to be x is equal to 9. Not so. But if I got x to the half is equal to negative 3. This here can be written as the square root of x is equal to negative. The square root of what number is going to give us negative 3? Nothing. Not so? So for the sum, no solution. So I want you guys to make a note here. If the denominator is an even number, the number has to be on the other side of the equal sign, the number must be positive. Okay? If the denominator is even, the number on the other side must be positive. So what if it's not positive? Did we just say? No solution. Yes?
No solution for both methods.
Yeah. Remember, mathematics works like this. Whichever method you to apply, and you're not making any mathematical errors, you should get the same answer. Always. Not so? So yes, it's a no solution for both. So what is that note? If the denominator is even, the number on the other side of the equal sign must be positive. If it's not positive and negative, then there will be no solution on the sum. Okay. Is the next two sums? I'm going to pause the video again. Do it both methods, okay? So, the answer to number 3? The answer is negative 1. Not so. So if I raise this to the exponent 3 over 1, that would simply be x is equal to negative 1 cube. If I apply the radical form, the cube root of x is equal to negative 1, how do I get rid of the cube root? Raise it to the power of 3 both sides. Not so. So that's simply going to be x is equal to. So either way, we'll give you the correct answer. Okay? You will understand. The next one, number 4. We raise this to its reciprocal. This will be half, and that will be half. Not so. So in other words, this will be x is equal to 2 squared raised to the half, which is x is equal to, no, x is equal to 2. That's not the right, okay? Because look here, if I go with the radical form, and I introduce a square root, but must not forget, plus minus. So x is equal to plus minus 2. Is this plus minus 2? No. It has to be plus minus 2. And the rule, if the numerator, remember now this is x2 equals 4, naturally that's over 1. If the numerator is even, and I'm simplifying, don't forget plus and minus on either side, left hand side or right hand side. And we'll put it where the number is instead of dividing again by plus minus. It won't go both sides because otherwise it will just cancel each other out. Okay? So the rule is if the numerator in the exponent is even, don't forget to add plus minus. And simplify. Okay, so if the numerator is even, okay, the numerator is even, don't forget to add plus and minus, and simplify on the other side. Right, you guys understand? Any confusion? No. So summary, to summarize, in the equation involving rational exponents, x to the half is equal to the root of x. Okay, this we know already. So we're going to do these two examples on page 13. Example 2 is also on page 13. I'm going to pause the video again. Okay, so what's the rule? If, what's going on here now? If the denominator is even, what must this number be? Positive. Is the number positive? Yes, so we can proceed. If this was not positive, I would just put a line saying it's not equal. Okay? So that's going to be x, the 3 over 4, raised to its reciprocal, which is 4 over 3. 8 can be written as 2 cubed raised to the power 4 over 3. Okay. So what do we do now? We multiply the exponents. That's always going to give you 1. And that is the reason why we're going with it. So that you can get a 1 in the exponent. And 2, the 3 is cancelled, leaves you a 2 to the 4, which is 16. Okay, any confusion there? You look at example 2. What's a note that I gave you with regards to the numerator being even? You must not forget plus minus. As you can see, the numerator is even. So it's going to be x, 2 over 3, raised to the exponent, 3 over 2. Is reciprocal, equals plus minus, 4 can be written as 2 squared, raised to the exponent, 3 over 2. Okay, so what happens? It cancels, so x is equal to plus minus 2, the 2's cancel, 3. Numerator and denominator cancel. What is 2 cubed equal to? What is 2 cubed? 8. So it's plus minus 8. So x is equal to plus minus. Okay, any problems there? No? So what I want you guys to do now is exercise 6, the odd numbers. 1.6, the odd numbers. Quickly. And now what did you say? This is on page 13. Yes, Michael. Yes or no? Okay. Number 1. If the denominator is even, this number has to be positive. Is that the case? Yes. So I'm going to square both sides. Therefore, x is equal to 24. You guys agree with that? Look at number 3. The numerator and denominator is odd, so nothing needs, no changes there. So I'm going to raise that to the exponent 3. Therefore, x is equal to 27. Look at number 9. The numerator is even. What must not forget? Plus minus. So I'm going to raise that to the power 3 over 2. 3 over 2. So going to be x is equal to 3 squared plus minus 3 over 2. So x is equal to plus minus 3 cubed, which is plus minus 27. Walaikum salam, how's it? Number 7, the denominator is even. The denominator is even. This number has to be? Is it positive? So I'm going to raise it to the exponent for both sides. Therefore, x is equal to number 9. The numerator is even. So what does that mean? Plus minus. I raise this to the power 3 over 2. Plus minus. So x is equal to 2 to the 4 plus minus 3 over 2. It will be plus minus 2. 4 times 3 over 2 is 6. And 2 to the 6 is what?
64.
64. Plus minus. You guys understand? This denominator is even. So this number has to be positive, which is the case here. Not so. So I raise it to the power 6 both sides. So x is equal to 60. Okay. Any confusion here, people? No. For homework, exercise 1.6, page 13, the even numbers. People, enjoy the rest of your day. Good afternoon, class.